We have 80-day 8954 here. This is the mono version. It's a built-in bridge rectifier, so this can be connected directly to an AC source or a transformer. Today we're gonna see how much this board can push into 8 ohms load. We're gonna use this power supply here. It's a symmetrical 40 volts power supply. Right, amplifier is now connected to the power supply. Just try turning on the it's looking good. It's pulling 26 watts from the AC source. We have 28.8 volts output peak to peak. So the fan is always spinning, it's always on. So it looks like it's not a temperature controlled fan. So let's increase the input to the amp. 56 volts. By the way, it's connected to our 8 ohms dummy load. The AC source has tripped. Set that on. The output is around 139 volts peak to peak before the AC source has tripped. So let's see what's the output RMS at 139 volts. 139 by 2.828 divide 8. So it's doing about 302 watts RMS at 8 ohms load before the AC source trip. In the short amount of time the dummy load is actually has hit up a bit. Just lower the input and turn on the AC source again. I've increased the current limit on the AC source at 3 amperes. We did not see how much the power supply is pulling from the AC source before it tripped. Would be nice if I had another camera pointing at the AC source, so we will be able to capture how much power the power supply was pulling before the source tripped, the AC source tripped. Okay, that's 140 volts peak to peak. We're pulling 341 watts now from the AC source. So it's still not clipping. We'll push a little bit before clipping. So there's a lot of noise now at the here and down here at the tip of the sine wave. So with 146 volts peak to peak output, the distortion is around 1%. We're at the 1% range here, and the pointer is exactly there at 1, so it's around 1%. Okay, so it's the clipping a bit. Because it looks like it's clipping now. It's clipping. Yeah, it's clipping now. You can see the top is a little bit straight. You just lower the input a little bit more, maybe 146 volt peak to peak. Okay, so that's the top. It's clean, so there's no clipping. So it's running about 146 volt peak to peak to 147, and it's now pulling 378 watts on the source, AC source. And the distortion is so that is 3%, so that is 3, so it's still around 1%. Yes, it's still around 1%. It's actually a little bit lower, around 0.98 to 0.96. So let's see the power output RMS at that is 146 to 147. Again, it's 147 volt. 47 divided 1.828 squared divide 8. So that's 337 watts RMS at 8 ohms load. So this amp really packs a punch at 8 ohms load. With two of this, we're going to have 600 watts plus. Is it hot? A little bit hot. I think I need to put a fan on there. So it's pulling around 381 watts now at the AC source. That's for an output of the 337. So there's about 40 to 50 watts power loss. That's including the loss in the power supply and the amplifier. So I think this amplifier is pretty efficient. It would be nice if I got an ammeter to measure the current going to the amplifier, so we can measure the efficiency of the amplifier. But looking at this, we can measure we can compute the efficiency, including the power supply and the 8954 the amplifier. So that will be 337 divided by 381. So it's about, this whole setup is about 88% efficient. So there's about 12% loss. I think that's pretty good for a combination of this supply and the amplifier. And the output seems pretty stable, still doing 146 to 147 volts peak to peak. This on all distortion, there is still not moving, it's still the same. Was planning on testing the amplifier with the 6 ohms load, but I don't think this power supply will be able to handle a 6 ohms load. Okay, that's it for today. Thank you for watching. Please subscribe to help the channel. See you next time.